Welcome to Pavitra Laptop Care. One of our subscribers has sent this schematic. It's confidential, compile confidential GPC 52 MB schematic document. But which motherboard it is? Really, I don't know. Okay. See, here is the model number LAJ643P. In this, he wants only voltage rail when it will generate. Maybe he is the basic or advanced level technician, that I don't know. But anyway. So let us check LAJ643P, what it is. J643, what it is? HP Pavilion gaming laptop. Oh, HP Pavilion gaming laptop. Okay, anyway, whatever it may be. So we will check what are the voltages and what are the signals will generate. Yes, see, here is the processor different and PC is also different. So it's a gaming only. Any gaming laptops, almost I am telling, the PCs will be separate and processor will be separate. This is the first concept you have to know. And second thing is voltage rail. See, it has given here this how we have to read. So here I'll make it little big. See, in any laptop, first concept is V in bat. Using these two, the common voltage we will get 19 VB. Okay. Using that, where it will go to PWM sections, multiple PWM sections. First PWM section is 3 volts always and the second one is 5 volts always. Okay, in that, before that, once it enters, so first we will get 3 volts VLP and next 5 volts VLP. Here it has not given, I think so. Okay, it's not used, so that's why nowadays 5 VL is not available. Anyway, they are using only 3 VLP. So this is the first one. These both are source, and using that source, one common source we will get, and next we will get 3 VLP, and next we will get always, and after this DSW, and after that some voltage will come from the IO. Then see, once these basic voltage is generated, then the main IO will be there. No, main chipsets, what we call it's smart chips, IO, processor and PCH. 3 will communicate each other one by one in particular stages. Okay, now what will happen once we get these common things, then a particular signal IO will release. Using that signal only we will get the PCH related voltage. Using that voltage, PCH will get active. Then what are the signals it will communicate? Later I will tell you. First he wants voltage rail, how to identify this. Okay, see, these are any applicable that I told you. These two are source plus this. Using this we will get one common voltage 19 VB. Second thing is the stage you need to understand. In all motherboards there are multiple sections, stages. Okay, one is S5 stage, S3 stage, then S0 stage. Only 3 you have to keep it in your mind. This you don't give more concentration on this. So why, I later I'll tell you. So these are the basic things in any laptop. If you are giving concentration on this, so older laptops you can't repair it. That's what I'm telling you. Anyway, S5. See, S5 here off. Which one is on? This one is on 1 volt. So 1.05 volts always is on. And again, if you come down here, one on is there. What is that? 1.8 volts always. See, here star mark has given, but some conditions is apply. Okay, and next on is here 3 volts always. Again one more 3 volts always has given, but what we will check later. So and again DSW also is on, and here one more VLP is on. So and here one more, it's a 5 volts always and 3 volts RTC section. Okay, so like this you have to read. First one is S5 stage, it is on, and remaining it will be off, right? So in S3 stage, what are the things it will be on? So those voltage we need to consider. See, again it's on. Okay, we need not to take because it's already on. So which one is on here? One more here it's off, and here is on. Which one? It's 1.2 VDDQ. It's a RAM related voltage, and here it's on, here it's on. No use, here off and on. So which one? 2.5. It means in S3 stage 2.5 and RAM related voltage will generate. Okay, next here off, here on, here off, here on. Which one? So that's it. Only RAM voltage in S3. Suspend to disk or suspend to memory, something. So S3 stage RAM voltage 2.5 and RAM voltage will generate. In S5 stage, all are on. So how it will generate and how it will be on? So let us check from the beginning. From the beginning means from source we will come. See, listen carefully. What are the voltage and what are the signals? Initially, it will start. So, where it will go? Those things you have to keep it in your mind. Now, it's a DC jack. It's 19 volts VDP. Usually, it's HP, right? So, in HP, multiple pins will be there. So, multiple pins are available. What are those? Here, it's 9 and 11. And 10 and 12. These are positive one. So, here two capacitors for charging and discharging. What it passes? Even bypass also. It will bypass AC and it will charge DC, and again it will pass here. When this power won't be available, then it will discharge here. So now through the coil it's little bit boost and we will get 19 volts V in. Here main voltage we got in second one is ground, positive negative two part entered. Now the circuit, the motherboard is a complete circuit. Finally it gives the display. Okay, so now it's a charge LED is 8. Okay, 6 one is adapter signal, here AC in LED. So usually in HP laptops, in DC jack we will get the charge LED light. Okay, so these are also signal from the IO, don't forget it. Okay, now the signal ADP signal, here also ADP signal was there, no, that one came here, and here adapter I underscore adapter ID, it went to IO. Now next here one AC LED ash. See, AC in LED, what it is? AC in LED. Here light has to come, no? For that AC LED ash, it will come from the IO. Bat charge LED. When we charge the battery, that time ambient light we will get, no? That charge LED. This signal also will come from the where? IO. See, this signal also going to the IO, here also it will go to IO, here also it will go to IO. See, now itself how many signals went to IO, but IO is not yet started, right? It's not yet on. It should be active, then only these all will work. How it will work at a time? So let us check. Now we got the main source from the adapter 19V in. Okay, and next if you come down, other source, it's the battery. Battery also, see, these are the pin are the positive. Using this positive we got this. So already explained this one. Through this coil we got this one. So these two are the source. And here what are the signals? See, here is the one signal, here is the two signal, and one more is here. These three are going to, it will communicate with the, these are bidirectional actually. It will communicate with the IO, charging IC and here battery. Okay, three section it will communicate. This data and clock, where clock will be there, their data also will go. And here battery information, what signal, 3 volts VL. Once we get this voltage, then only we will get this information. Okay, anyway, let us check what are the voltage we will get using what, using these two source. Now source we got 19 volts V in, will come by the source. See, this 19 volt source has connected to the drain of the first MOSFET. Okay, so here it has come, here it's a drain concept, or drain to source it won't go. How, when it will go, here it should get the gate voltage, some particular gate voltage, threshold voltage we will call. So it should be greater than drain source, drain voltage. So here it's 19 voltage, here approximate 24 to 25 voltage it will get, or more than that also, or less than, little bit less than that also. Once it gives, once it receives, so next section, see here AC drive, through this IC it will receive the voltage, and once gate voltage comes, then it will pass here, we will get this one. Both gate will be on now, so easily this voltage also will pass here, and finally what voltage we will get, 19 VB through the adapter. Okay, now here is the battery voltage. What is that battery voltage? Here 16.8 volts battery. Then from where it will come? Here it will come. Okay, so in this is called discharging MOSFET. This one how it will work, multiple times I already explained, so go through one of my video. Now what we got, now we got 19 VB. Okay, now this charging IC is not completely on, because here data and clock will be there. No, that for that we required 3 VLP. Okay, when we will get, then only this particular IC will get on. Before that we will get only 19 volts, and that also it will goes as a input. Okay, here what will happen? See, here AC in is there. AC in means AC detect. Here is the voltage divider. One particular voltage approximate 2.8 to 3.3 voltage will occur here. So this IC will detect AC is connected or not. That is the information in charging IC. Only one condition will be, it will be on. Only AC AC in. And if supply is connected to this, then DC in supply will goes to this particular charging IC. See, where the here supply. So 19 V in. Even from the battery side also, through this 3-leg diode, it has gone to this particular charging IC. Now this charging IC is active but not completely active. Okay, now it will recognize the battery side CLR section, and here main voltage CLR section it will recognize, and here AC in also will be active, and AC OK will be active or not. AC OK through this VC in AC OK, this also will be active. Okay, now this one won't be active now. So how that I will check, I will tell you that how it is. We need to find out this 19 VB. Now 19 VB came here, this IC input, and immediately what is this? This is 3 volts always IC. Okay, this 3 volts always, what are the voltage will generate here? Immediately 3 volts VLP will generate. Once 19 volts it reduces, and also 5 volts where it is, where it is, here is a LDO, and one more LDO where it is, here not given. This is only 3 volts always. Okay, always we will be searching 5 volts also, right? No, this is only 3 volts IC. Okay, that one what we are searching, that is available in this particular IC. Both ICs are different. Okay, in previous days one IC has will be having 2 phases, the one for 3 volts and other one for 5 volts. That's why here we are not able to get it. This is 3 volts IC section. Once 19 volts will come, we will get 3 VLP, and once 19 volts will come, we will get 5 volts VLP. See, what about the enable? Enable from where we will get? If we get enable these two from the 19 volts, then definitely immediately 3 volts always also we will get. See, through the 19 only we are getting the enable signals. And one more thing we need to keep it in our mind, the EC on. See, once this 3 VLP comes, then immediately that IO will be active. The IO required voltage is 3 volts always or 3 volts VLP. See, once 19 volts comes, this enable will be active, and finally we will get that 3 volts always. That one P will be converting as only always. Here 3 VLP is converting as 3 VL. Okay, now what are the voltage we got? We got 3 volts always and 3 volts VLP. And here also 5 volts always and 5 volts VL we got. Okay, these are the main voltages. See, once you press the power button or before this power button, EC on should come. First you need to check your laptop, it's coming before pressing power button or after pressing power button. These two signal, once it comes, these are the enable. Okay, this will be active, this 3 volts always and 5 volts always. According to that power rail, it will active before. Means maybe after pressing the power button also. This 19 volts enters here also. See, this one is what? It's a dual MOSFET. It will come and it will be stay here. This one is PWM section of RAM. And next, the same 19 VB will come to PU100. What it is actually, this IC is 1.05 volts always. See, this one is depends on this 1.8 volts PG power good. Okay, any other voltage here? Yeah, 1.8 is here. See, for that this voltage has to come. So till now this one not yet come. This one is always, once 3 volts always will come now, that time only this 1.8 volts always will generate when the PCH prime comes. Okay, now here that power good, this IC power good should come here, then only this voltage will active. Now what are the always? 1.05 volts always and 1.8 volts always is little bit pending because of the enable signals. See, the same thing will come to CPU VCC core section also. And what are the high MOSFETs will be there in PWM section? All high MOSFET will receive this particular 19 volts in drain. Okay, this is the concept here. 19 volts. 19 volts is finished. Even that LCD section also, the fuse will be there. No, fuse section also. This LCD, 19 volts VB will go. Okay. Now V in over BAT plus over 19 VB over. Now what voltage we got? Now we got 3 VLP and 5 VLP. Okay, 5 VLP here is not given. Okay, leave it. So now 3 VL, what are the signals and what are the voltage will generate using this? See here 3 VL through this diode, what it becoming? It's becoming 3 VL RTC. So this one is very, very important section. Now RTC section in the PCH will active. So here somewhere, okay, total RTC section will active using that 3 VLP. Here using this power button out signal, and here SM clock 2 and data 2. See, this is the main supply to the IO. Here it's input to this through this coil. It's become this VCCA, and here the supply. Using this 3 VL, the 3 volts lead also will generate, okay, by these voltages. And finally lead switch, it's going to where? IO. Here through this 3 VL, one of the diodes, see, using this diode 3 volts SM bus also generating. Here G sensor, this is a gaming laptop, right? So that's why accelerator G sensor something will active. Here one signal USB in status hash. See here the gate voltage, once this voltage will come, then this LED will convert as on and off switch. See here at the beginning we came, it's a battery input, it's a pull up. 3 VL is the pull up for battery information. Here is 3 volts VL is the pull up for this processor heart information, and here is the bypass section. That's it, 3 VLP over. Now 3 volts always using this GPD7, one signal is going to where it's strap, it may be PCH. See, in this path this 3 volts always is becoming DSW. Okay, here one voltage SDP, HPD. See, one more jumper is the JP3. It should be in open condition. Otherwise, directly this 3 voltage will convert as PCH prime. But it will be in open condition. Please check in your motherboard. So once PCH power enable signal comes, then only this one will convert. See, these are 3 VLP generated voltages. Here, this directly goes to IO. Once the IO is active, it reduces the voltage, then automatically this signal it will release. These are the output from the IO. Now we will get the light in where DC jack. Okay, this charging, if you connected only adapter, it will be in white light LED, and in case the battery is charging, it's amber LED will be there. Okay, like this we will get the LEDs in adapter ID. That is the indication. Once 3 volts always and 5 volts always is good, then the step down voltages, basic voltages, that PWM step down IC is okay. Okay, that is the indication here. So now 3 volts always and VLP we got, right? So using that, this charging IC, it's completely now it will work, and it gives some voltages. What is that? ADP I, discharge I, and some signals, actually those are signals that directly goes to where? IO. Okay, SMD clock and SMD data. Here ECMC, SMB clock 1 and data 1. So charging IC, battery section and IO section, these 3 will communicate, and now the battery will charge. So these are the basic voltages. Using that, always what are the voltage we will get, what are the signal we will get, that I already explained you. So please check, please confirm these voltages. Now what will happen, once these voltages will come, immediately all voltages are okay, then immediately IO will release, what is that? Power enable. What is that? PCH related power enable. PCH power enable. Using that, what will happen, that we will check. See here, pin number 107, IO pin number 107, it releases PCH power enable. See here, once PCH power enable comes, then this IC will active, then this 3 volts always will become PCH prime. In previous motherboard, some logic were there. Okay, so some MOSFETs logic and some transistor logic were there. Using that, it was converting 3 volts always to this one PCH prime. But now directly using this IC, it's converting as this one by once it reduces this PCH power enable. Okay, otherwise other shortcut also is there. If you short this directly always and PCH prime, everything will be inactive. So it means starting itself the PCH will be inactive condition. Now we will check this PCH prime, where it will go and what it will do. See this PCH prime, 3 volts PCH prime, using this PG, this is actually power good enable. Okay, now 3 volts always we got, and here one more PCH power enable signal is there, that is the enable signal. Once this enable signal will come, then 1.8 volts VLP will generate. This 1.8 volts volts always will generate, it will generate. Okay, so now again we will search what are the voltages it will generate. See, using this PCH prime, these all USB related signals are released. Here also PCH control clock data, see DP1, DP2, DP3, all related PCH prime. Here also PCH wake, PCI wake. See here always is converted as DSW, right? So using that here LAN wake hash, and this one using this, what is that, here system reset hash is generating. Here PCH SML data clock 10 and normal SMB. Here PCH SML alert. Here Bluetooth on, wireless off, GPU event, HDD halt LED, and here I2C clock and data. Here it's converting as PHVC, and here same thing USB 2, and here PHV LDO. Here the voltage is going to PCH. Here the SSD voltage, see some logic is there here. That's it, the prime voltage. And now this 1.05 always what it does, so that we will check. This one and 1.8 also both. See, this is pull up for this signal. Here that PHY related voltage it's converting here directly. See here 1.0 PCH. Here also some fuse, using this fuse HV LDO USB VCC, and here PLL EBB, and here SRC CPLL1. See, so many voltages are converting 1.05 volts PCH. See 1.05, that's it. Now we will check 1.8 volts always. Here it's converting as the prime voltages. Here also we need to check so many signals we will get. So this also over. Now that PCH what it's doing, that also we will check. It has gone to strap signal, and here also one more strap, here also one more, and here also one more. Here it's going to PCH, see here and here. Here two signals, this PRX and PRX DTX, see this one and this one. That's it. Now we will check 5 volts always. Here is a signal. Here it will go to IO board. See here, one more voltage conversion is happening here, 2546 power. This is very important one, but in deeply I will tell you some other time, because here once SP OK, from where it will come? It will come 3 volt section power good, I think so. From that here it will be present. Once it presents, so here there will be no voltage, and then it will be in off condition. then 19 volts will enter here, and then here the voltage here present means it will convert here once you get this SPOK. Okay, so what it is later also we'll check. That's it. 5 volts will enter almost all CPU core ICs and some other important IC it will enter, but some other signals also required. That's why I'm not explaining those things. So now 5 volts always also over. So now what are the basic voltage, everything I explained. Now what will happen? So all basic voltages, S5 stages, what voltages we have to get, all signals and voltages is present now. So at present in this condition, what is that? IO, once it releases power enabled signal, PCH power enabled signals, all PCH sections, almost all PCH sections blocks got enabled. Now in this condition, even PCH also enabled, and here I also enabled. Here one more signal will go to PCH. What are those? Not only one, little bit multiple. So that one is, once press the power button, the power button related voltage, power button out, lid out, and RSM RST. So these three signals, this is the RSM RST is the last signals. So before pressing power button, no, after pressing power button also. Okay, once you press the power button, these reset, till that reset all voltages should be present. If anyone is absent or anyone malfunctioning is happening, then here RSM RST will be keep on enable. If RSM RST is keep on enable, it won't go to PCH. PCH information, what it will be, the basic voltage has some issues, that information goes to PCH. Then the PCH won't give some other signals to the IO. In case that is disabled, what is it? RSM RST is once enabled and disabled, then PCH will understand all basic voltages are good. So then using that signal, the PCH will release 3 or 4 more signals. It gives to IO, or in some other conditions it directly gives to some PWM sections. What are those? SLP S5, S4, S3 and sus clock. So these all are the signals IO will release. So once these are the signals it releases, then this IO will release what? What are the voltages? Cis on and sus P hash. Okay, cis on and sus P hash. See, once these voltages, these signals are available, then multiple PWM sections will generate. First, in this condition, the first thing is S3 stage. What are that? RAM section voltages will produce. It's a 1.2 volts and 0.6 volts reference VTD voltages. These two will generate. Using that, what are the required signals? What are the required voltages will convert? So those things will convert. Once this RAM voltage will come, then then what are the DC to DC voltages? Remaining one, it's a VS related. 3 volts VS, 5 volts VS, 1.8 volts VS. Everything will generate as we saw the voltage rail. So we will go to voltage rail section. See here, what are the remaining voltage? So VS related. This VS first, this one will generate. This one will generate. So using this and this all VS related voltages, JFX, all will generate one by one. So these things, this is homework to you. Actually till now I given some guidance, some hints to you. So using that, what are the converted voltages? Now I explained you how the PCH will convert. That voltage will convert DC to DC. So like that only VS also will convert in one stage. So those things, what are those? See, 3 VS, 5 VS, and this one, it's 1.8 VS, and this one 0.95 VS, 1.05 VS. So all things you need to check thoroughly, and how it will generate, that you come to know one by one. Okay, this one was the voltage rail step by step in order how it will come, that I already explained. So note down it. If you not understood, So once again you have to watch this video. So once again you have to watch this unless you get the idea. Don't go further sections, because till here you need to understand properly. Then only that susp hash what it will generate, everything you can know. So this is the thing, voltage rail from S5 stage to S0 stage. Till S3 I explained, so S0 is homework to you. Okay, understood? If you have any doubts, so please put it in comment. Again I will explain to you personally or through the video or through the telegram. That's it. Thank you very much.